Okay, so your numbers were kind of blurry, but I choose a very, very similar problem, and you can do it, similarly. So I am trying to explain this problem. This is very similar to your question, so it should help to, this should be helpful to you anyway. So now the first one says that what's the domain of the applied function? See, the time, the t here, which is the independent variable, is going to be a set of domains because this object is falling at a certain height. So it's sort of like this. If I draw you a picture here, S0 here represent the initial position, right? So S0 here is somewhere right here, and then when the object is dropped, this parabolic shape, and this is going to be the maximum height, and it's going to hit the ground right here. So this is like S0 here. So then the domain, therefore, it's going to start at 0. So it's going to be from 0 to infinity, possibly, right? So I will write this here, 0 to infinity. Okay, domain of this function. And then it says that let's say we're trying to find, okay, what are you trying to find? Maximum height about the ground. So we're trying to find this point, and this point is actually a vertex point, but the initial velocity, which is v0 here. So if I rewrite this function is going to look like this: negative 4.9 t squared plus 12, because v0 is 12, and the initial height is 0. So you don't need to write anything here. Now, to find the maximum height, what's the marble's maximum height is just going to be this. First, I'm going to find h, and remember h is negative b over 2a, which b is 12. So this is negative 12 divided by 2 times negative 4.9, negative 12 divided by 9.8, negative 9.8. Okay, let's just calculate this. So here you're going to need, you're going to need a calculator. So I suggest that you do that. So it's 12 divided by 9.8. Okay, 12 divided by 9.8 should be 1 point. So this should be 1.22. And then plug that into the function to find a k, because k is going to be the maximum value here. So when you plug it in, it's going to be negative 4.9, 1.22 squared plus 12 times 1.22. Okay. Complete this. So 1.2 squared, 1.22 squared, and then multiplied by negative 4.9. So multiply by 4.9. That's like, this is like negative 7.29316, and plus 12 times 1.22, and that's going to be 14.64. Now just subtract these two numbers because one of them is minus, so it's minus 7.29316, and that's going to be 7.34684. And the question says round your answer to the 2 decimal places. So I guess this will be, okay, so it's like 374, right? So this will be 7.34. That's going to be the maximum height. Okay, for this problem, right? Now it says at what time it will hit the ground. At what time it will hit the ground. So when it hits the ground, the height is going to be 0. So when it hits the ground, then this S0 is going to be, the S here, right? S right here is going to be 0, not the S0. Sorry, S0 is the initial height. Just the S is going to be 0, right? So therefore, I will just do this. I will have negative 4.9 t squared plus 12 times t equals 0. Then I can just factor t, which is negative 4.9 t plus 12 equals 0. Then t t equals 0, set the factors to 0. And then if you set this guy to 0, then you're going to get t equal to 12 divided by 4.9. 12 divided by 4.9 is, let's see what that is. So 12 divided by 4.9, that's like 2.44, and we have to round it 2 decimal places. So it's like 2.44. So after 2.44 seconds, then it will hit the ground. And then now for part C, it says now, okay, the top of the tower, which is 25 meter tall, when does it hit the ground? Okay, now, okay, so the S0 is 25 now. So this is S0. So you're sort of going to repeat the similar things for these two steps. So S0 is going to be 25. So then your function is going to look like this: ST equal negative 4.9 t squared plus 12t and plus 25. And when does it hit the ground? You have to set this to 0 and then solve this for t. So for t, and then that will be the answer to this question when you solve it for t. Now for part D, it says what will the height of function be if instead of shooting the marble off the tower, where you shoot straight down with the initial speed 12. So when you since it is shot down, so this will be negative 12. So initial speed will be negative 12 from 25 meters. So this will be the initial height. So therefore, for part D, the function is going to be this. The function is going to be negative 4.9 t squared minus 12t. So you will put this guy in here, because if it's going down, then it's going to be negative. So speed is going to be negative, and the height is still 25. So that's pretty much it. The only part that you will have to really be careful here is, just solve this for t. You can use a quadratic formula if you want, because it's just a quadratic equation. Okay, hopefully this will help you to solve your problem.